Welcome back. Self-consistency is an advanced prompting technique designed to enhance the reasoning capabilities of generative AI models. As for the tree of thoughts technique, self-consistency moves away from the linear, step-by-step path to problem-solving of the chain of thoughts. Instead, it introduces a more dynamic and robust methodology to generate multiple reasoning pathways for a given query or problem. Before diving into the self-consistency technique, I would like to make an important point that you have probably figured out already. Large language models like ChatGPT do not inherently understand concepts like chain of thought or self-consistency in the same way humans do. Instead, these models operate based on patterns and associations learned from the vast datasets on which they were trained. The effectiveness of techniques like chain of thought or self-consistency largely depends on how the prompt is structured and provides a directive that shapes the model's behavior. It doesn't change the model's underlying mechanics, but influences how it applies its learned patterns to generate responses. Essentially, the prompt guides the model to simulate a reasoning process or to generate multiple perspectives and then evaluate them. There is an important detail, though. While the prompt directs the model's output, the quality and relevance of the response still depend on the model's capabilities, which are a function of its training data, architecture, and tuning. A model can only generate outputs based on the information and patterns learned during training. While traditional chain of thoughts prompting guides a language model to articulate each step of its reasoning explicitly, it is limited by its linear trajectory, often only exploring one potential path to a solution. This limitation can sometimes result in less accurate or contextually inappropriate responses, particularly in complex scenarios where multiple variables or interpretations are possible. Self-consistency was introduced in 2022 by Wang et al. In their paper, Self-Consistency Improves Chain of Thought Reasoning in Language Models. The technique was explored to enhance the capabilities of language models to solve mathematical and logical problems by employing multiple reasoning paths and aggregating them to find the most consistent and accurate answers. The key innovation of self-consistency lies in its ability to prompt the AI to consider various possible reasoning paths from the outset. Instead of committing to the first plausible path, the model generates several explanations or solutions. Each path represents a distinct line of reasoning, which can vary in their approaches based on different logical interpretations or factual bases the model considers. After generating multiple reasoning paths, self-consistency does not simply select the most common answer among them. Instead, it employs a sophisticated aggregation mechanism to analyze and synthesize these diverse paths. This process involves weighing the outcomes based on their logical soundness, the completeness of their reasoning, and their alignment with known data or facts. The final response is thus not only a product of multiple thought processes, but also a refined answer that potentially holds a higher degree of accuracy and reliability than those generated by traditional methods. To no surprise, the process begins from the initial prompt. In self-consistency prompting, the prompt is structured to encourage the model to generate multiple independent reasoning paths or answers to a question. This can be achieved by explicitly asking the model to consider different approaches or perspectives in its responses. The prompt is then submitted to the language model. The model generates multiple independent reasoning paths instead of generating a single and sequential reasoning trail, as in the chain of thought. Each path represents a different way of thinking about the problem, similar to having multiple experts analyze the question. These paths may vary significantly, covering a range of logical strategies, perspectives, or even hypothetical scenarios. This diversity is crucial as it avoids the biases and limitations of a single line of reasoning. From these generated paths, a subset is sampled. This sampling could be random or based on specific criteria, such as diversity or the perceived quality of the reasoning. To find the most consistent answer, the model or an external system will analyze these sampled reasoning paths and perform what is known as marginalization. In this context, marginalization involves evaluating the distribution of answers or conclusions across all the sampled paths and identifying which answer appears most frequently or consistently. This is similar to taking the majority vote or consensus among all the sampled paths. Given the diversity of approaches leading to it, the idea is that the most frequent answer, which recurs across multiple independent reasoning paths, is likely the most reliable or true answer. The answer with the highest consistency across the various paths is selected as the final output. This method naturally filters out outlier responses and errors that might occur in individual reasoning paths. As the authors explain, such an approach is analogous to the human experience in that if multiple different ways of thinking lead to the same answer, one has greater confidence that the final answer is correct. The rationale behind using such an approach is that it leverages the collective wisdom of multiple thought processes the model generates, thereby mitigating the biases or errors inherent in a single line of reasoning. By focusing on the answer that has the most support from different angles, the model is more likely to arrive at accurate and robust conclusions, especially in complex problem-solving scenarios like math or logic problems. Let's apply the self-consistency technique to a business problem. As for the chain of thought technique, we will provide the context around a business problem related to the launch of a new eco-friendly cleaning product in a very competitive market. Let's see how our generative AI will fare. The task is to generate and evaluate multiple marketing strategies, considering different customer segments, channels, and marketing messaging. Because the language model is unaware of its ability to execute this task using a self-consistency technique, we need to instruct on how to solve this problem using a self-consistency approach. As the first step, we ask the model to generate multiple strategies focusing on different customer segments. You must have a good idea of your marketing segments, and in this case, a prior customer segmentation analysis is required. For each segment identified in Step 1, we then ask to develop a marketing and messaging strategy by providing several strategic paths on what channel to utilize and the type of messages. The third step is the analytical and aggregation step, which identifies the best strategy. Notice the marginalization approach we ask the model to take by identifying consistency across the various paths. The consolidation step aggregates the marginalized results into a comprehensive marketing plan with the needed details. Finally, we ask the model to generate a detailed marketing strategy with specific actions to achieve the expected outcomes. Additionally, we ask to generate KPIs to measure the progress of the selected campaign. Let's summarize the elements we provided to the language model in a self-consistency prompt. The first step is to define the problem or question by specifying the context and the general task we want the large language model to solve. In our example, we provided a clear context together with a specific task for the LLM to solve. We then instructed the LLM to generate multiple and independent reasoning paths by identifying various customer segments and develop marketing channels and messaging for each segment. Next, we asked the LLM to aggregate the paths to find commonalities or a consensus by analyzing, evaluating, and aggregating the potential impacts of each strategy on each segment, and from that analysis, determine the strategy that is most likely to succeed. Finally, we instructed the LLM to synthesize and consolidate the results by generating a comprehensive marketing plan containing the most effective tactics for the selected strategy. The self-consistency prompting technique offers a robust approach to enhancing the accuracy and reliability of responses from language models. By generating multiple independent reasoning paths and synthesizing a consensus from them, this technique effectively leverages the model's diversity of thought to arrive at well-rounded and dependable conclusions, making it especially valuable in complex decision-making scenarios where precision is paramount. Next, I will show you a very different technique to extend knowledge when we need to derive new information. Coming up,